Welcome to the fastest way to learn data structures and algorithms. Today, we're mastering a fundamental backtracking challenge, LeetCode 79, word search. This problem is the ultimate test of your recursion and grid traversal skills. If you can solve this, you're well on your way to mastering depth-first search. Here's the setup. We're given an m by n grid of characters and a target word. Our job is to determine if that word exists in the grid. We can move horizontally or vertically to adjacent cells, but there's a crucial rule: we cannot use the same cell more than once for a single word. If we find the sequence, we return true. Otherwise, it's false. Think of this like a treasure hunter exploring a dangerous ancient temple. The floor is made of pressure plates, each marked with a letter. To unlock the treasure, you must step on the plates in the exact order of the secret word. But be careful. Once you step on a plate, it's locked until you leave that specific path. If you hit a dead end, you must carefully backtrack, resetting the plates as you go, to try a different direction. To solve this, we'll use depth-first search with backtracking. We'll iterate through every cell in the grid, looking for the first letter of our word. When we find a match, we launch our DFS. From the current cell, we explore all four neighbors up, down, left, and right. To ensure we don't reuse a cell, we'll temporarily mark it as visited by changing its character to a placeholder like a hash symbol. After exploring all directions from that cell, we backtrack by restoring its original character. This allows other paths to use that cell later. Look at our grid. We're searching for the word apt. We scan the board and find it at row 0, column 0. Our DFS begins. From A, we look for B. We find it at row 0, column 1. From B, we look for C. We find it at row 0, column 2. From C, we look for the second C. There's one at row 1, column 2. We move there. From this second C, we look for E. We find it below at row 2, column 2. Finally, from E, we look for D. It's right there on the left at row 2, column 1. We found every letter in order, so we return true. In our Python code, we start by getting the grid dimensions. We loop through every row R and every column C, calling our DFS helper for each cell. The DFS helper takes the current position and the current index of the word we're looking for. First, the base cases. If the index equals the word length, we've found the whole word. Return true. If we're out of bounds, or the current cell doesn't match the word at our index, return false. Now, the backtracking magic. We save the original character, then mark the cell as visited. We recursively call DFS for all four adjacent directions. If any of those return true, we're golden. Finally, we restore the original character and return the result. Simple, elegant, and powerful. For time complexity, in the worst case, we explore four directions for every character in the word, leading to O of n times 3 to the power of L, where n is the number of cells and L is the length of the word. For space complexity, the recursion stack can go as deep as the length of the word, so it's O of L. And that's how you navigate a grid like a pro using backtracking. If this visualization made the logic click for you, hit that like button and subscribe to Leo Academy for more premium DSA explainers. See you in the next one.